Let's talk planets and gravity. First, make sure we understand the questions we want to answer. Can you describe the physical properties of planets and their location within our solar system? And then can you describe how gravity is demonstrated between those planets, as well as between the sun and the moon and the planets? Back up first and make sure you understand the definition of a planet. A planet has to be a celestial body or a thing in space, mostly spherical, and it actually travels in an elliptical orbit around a star. In our solar system, that star would be the sun. Planets are often characterized based on quite a few features. It could be color, their proximity to the sun, their size, the speed that they travel around the sun, their density, to how much stuff they're made of, and then the physical and chemical makeup, so what stuff they're made of. In our solar system, we took part in utilizing the proximity of the sun to group our planets. We have the inner planets, which are sometimes called the terrestrial or rocky planets, and I'll also explain the outer planets in a few moments. But the inner planets are the ones that are closer to the sun. That includes this guy Mercury right here. We got Venus, Earth, and Mars. These planets are closer together within themselves, and they're also, again, mostly made of land or a rocky terrain. Terrestrial is a fancy word to describe a land planet. Because they're made of solids, they are more dense than other planets. You can actually walk on a land planet like Earth. They're smaller in size, and because they're closer to the sun, they actually can travel or revolve around the sun in a shorter amount of time than other planets. Alternately, our outer planets, which are given, the name is given to these guys, Jupiter, Saturn, Neptune, and Uranus. These planets are farther from the sun and they're further apart. Now, you might hear other terms instead of just outer planets. You'll hear them called gas giants or Jovian planets. These are all different names for the same type of planet. But they're further from the sun, and even traveling from one planet to the next could take years. In fact, I would probably die before we got to some of the further extremity gas giants. You guys would just be super old, or you might die too. But within the terrestrial planets, for example, Earth to Mars, depending on the orbit, you could get from one planet to the next in 6 months or a year. So the terrestrial planets, again, are closer together. These gas giants are just massively spread apart. And they're mostly made of gas. You really can't walk on a gas giant because it's made of gas. And that means they're less dense. In fact, Saturn is less dense than water. So if you could find a bathtub big enough, you could put Saturn in it and it would float because it's less dense than water. But again, they're huge. Their volume, the space that they take up, is really big. And they're further from the sun, so it does take them a longer time to revolve or orbit around the sun. We also don't know much about the gas giants. It's important to remind ourselves of gravity when we're talking about all these planets interacting too. Gravity is a force or an attraction that's exerted by a celestial body, so by a planet, on other objects near it. So planets can exert gravitational forces on other planets, on moons, on other bodies nearby. So gravity is an important component to discuss within our solar system. Now, one question you could ask is, how does the mass of an object affect the gravity? Well, the greater the mass, the more stuff that it's made of, the more gravitational force that it can exert on an object around it. So that means, for example, our sun is huge. It's the hugest thing in our solar system. It has such a strong gravitational force or pull, it's what keeps all the planets in orbit around it. But on a smaller scale, you could have the moon, the Earth's moon, exerting a gravitational force on the Earth, and the Earth can exert a gravitational force on the moon. So gravity is at play in multiple places within our solar system. So if the sun is so mass and it governs all planetary movement in the solar system, then the gravitational force between smaller objects doesn't matter, right? Wrong. In fact, the proximity of two objects together can be a huge impact on their gravitational force. The closer they are, the more gravitational force they'll have. For example, when we talk about the Earth and the moon, as the moon revolves around the Earth, its gravitational pull has a greater impact on the tides versus the sun. The sun's still keeping everything in orbit, but that moon actually determines how the bodies of water on our planet are literally pulled into spring and neap tides. So proximity can be a huge part of gravitational force. We also want to talk about how the planets move within our solar system. They do all orbit or revolve around the sun. Neat fact, they don't actually all go clockwise. Venus and Uranus actually rotate counterclockwise. Fun fact, not sure if you knew that. The sun, again, does keep all the planets nearby. You can see in this picture, though, how the elliptical orbits of the planets are all similar or on the same plane, except for Pluto. So poor little dwarf planet Pluto, his little cattywampus elliptical orbit is one of the reasons he was kicked out of the planet club. But they do have an elliptical shape. And now it's time to jump right into all the planet characteristics. Remember, one of our first goals was, can you describe the physical properties of the planets in our solar system and their location? So the first planet is Mercury. Mercury is the closest one to the sun. It's the smallest planet in our solar system, and it's actually the second hottest. My favorite fact about Mercury is that it has no atmosphere. So because there's no atmosphere, no force field around the planet, it literally can get hit by all kinds of asteroids and craters. It's covered in, if you look at the surface of Mercury, it's covered in craters. And again, it's closest to the sun, so it can get around the sun the fastest. A year on Mercury is only 88 Earth days. Then we'll move on to Venus. Venus is one of my fave planets. So Venus is the second one closest to the sun. And it's actually called sister planet because it's the same size as Earth. What's totally different about Venus, though, is its atmosphere. It actually has a very thick atmosphere. It's loaded with carbon dioxide. So some people, because it has a thick atmosphere and it's the sister planet to Earth, some people call Venus the thick sister. That might work for you. Remember it if so. But scientifically speaking, we call it a thick atmosphere because of the CO2 that's surrounding it. And it traps heat from the sun. Remember, it's the second closest planet to the sun. And it does have the atmosphere. So it traps all that CO2 in and makes it crazy hot on the planet. It has a revolution a little bit shorter than Earth, too. It's 243 days, makes a year on Venus. Then we move to Earth, which you guys know a little bit about. This is the planet where we live, and it's made of 2/3 water. It's the only planet right now known to support life. It has a fancy magnetic sphere or force field, but magnetosphere is the scientific term. And that is what deflects all these harmful solar rays. When you've learned in the past about the sun, and just recently in our digital notebook, the sun exerts some pretty harmful rays. And this magnetosphere that we have around our planet deflects a lot of that and prevents us from having harmful radiation all over the surface of the planet and on our bodies. The revolution, for Earth was 365 days. You guys know that to be a year. Next, we'll move on to Mars. Mars is also known as the red planet. And if you were to look at surface features of Mars, they have peaks and valleys just like on Earth. There's lots of topography. And the Grand Canyon of Mars makes our Grand Canyon look like a baby. So features on Mars are much more enhanced than those on Earth. Mars, like Earth, also has lots of weather. What Mars is known for are these large dust storms. In fact, they've been so bad, some of the rovers and robots that are on Mars exploring have gotten caught in these dust storms, covered in dust, and actually their solar panels couldn't access sunlight. So they would sit idle. They couldn't get power. So the dust storms on Mars can be pretty intense. Speaking of these rovers, there are unmanned, so no people have been on Mars, but scientists have sent things called rovers, which are these moving robots, and landers, which are stationary components on Mars, and they're exploring so many aspects of Mars. Seismic activity, so does Mars have plate tectonic movement like on Earth? They've been collecting soil samples, atmosphere samples. The ultimate goal is to send people to Mars at one point. So that's where all the studies are being put forth now. The revolution for Mars, or the year on Mars, is 687 Earth days. So a year on Mars is going to be a little bit longer than on Earth. Our next planet is when we actually jump into our gas giant component. So, point to make, once we left Mars and went to Jupiter, before we got there, we actually traveled through what kind of belt? Asteroid belt. Woohoo! Good job if you got that right. So let's pretend we've traveled through the asteroid belt and we're now at Jupiter, which is our largest planet. And remember, these gas giants are spaced out, so we've been traveling a very, very long time. Most people, when I mention Jupiter, you immediately think of that giant red spot. It is a storm that's occurring on Jupiter, and you could actually fit 2 Earths inside of just the storm. So Jupiter's big. Galileo also discovered that Jupiter has many, many moons. So remember that whole gravitational force? Jupiter's huge, so it can exert a lot of gravitational pull on planets around it. It's also got lots of moons, so you could have a lot of gravitational play. Just a fun fact, Ganymede is the name of the largest moon in our solar system, and it is one of Jupiter's moons. Jupiter, because it's so far away from the sun, it actually takes 12 years to get around the sun one time. Our next gas giant is Saturn, and Saturn is known for its many rings. Those rings, if you haven't been told, are made of dust and ice, and it's a very low density planet. Remember, it could fit in a bathtub and float because its density is less than 1. And it takes 29 Earth years to get around the sun. So remember, Jupiter was like 12 years. Saturn is so far away, it would take 29 years to get around the sun one time. Then we move on to Uranus, which is the proper scientific way to say this. And what is cool about Uranus is that its axis, we draw planet axes mostly vertical, maybe a little bit of a tilt. But the axis on Uranus is totally sideways. So when it rotates north and south. It's totally weird. It has 13 sets of rings, which is not a very common fact. Some of the rings are partial. And Voyager 2 is the name of a satellite that has passed, I think like in 79. It's been a while. But Voyager 2 was a mission a long, long time ago for you guys, and it was able to take photographs as it passed by some of these gas giants. And remember, we're spacing our planets out 84 years, guys. It takes 84 years for Uranus to make one rotation or one revolution around the sun. Crazy! And then let's move on to our last official planet, Mr. Neptune. And it's actually smaller than Uranus, but has greater mass. So there's more stuff compacted into that smaller space. And like Jupiter, it has this storm, but instead of being called the Great Red Spot, we call this the Great Dark Spot because it's a dark spot on Neptune. Voyager 2 also passed by this planet and was able to photograph it. And the revolution It gets bigger and bigger. It takes 165 Earth years for Neptune to get around the sun once for one revolution. One more thing. Can you name all these planets? Could you name them in order without looking? If you need a mnemonic device to remember, think of "My very excellent mother just served us nachos." That helps you remember Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.